We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Good morning, everyone. Today we are going to learn about the debugging, which is importance for dynamic malware analysis. Basically, the difference between disassembler and debugger is that a debugger is a piece of software or hardware used to test or examine the execution of another program, right? And debugger help in the process of developing the software, that we very well know, right? Because every time, either in any language, when we are implementing something, any program or any software, we used to follow the debugging process. Okay, so you all aware about this process. Now here we want to see what is the importance of debugging process in malware analysis, and particularly in advanced dynamic malware analysis. See what happened in disassembler that we have already learned in IDA Pro, that it shows the state of the program just before the execution begins, while debugger shows that every memory location. It shows the register details and whatever the argument which is passed for each and every functions. And another thing, that during this process of debugging, at any point it is allowed to change by the user. Means if you want to change any point or any value during this process, then you can do, right? So these are the some basic differences between disassembler and debugger. And basically two debugger which is very much useful for malware analysis. One is only DBG, that is particularly used for user mode debugging, and another one is WinDBG, that is used for the kernel mode debugging. See, both are very much important debugger, and currently we know that there are so many advanced softwares available for malware analysis. Like yesterday we have learned about the Hydra open source tool, which is a kind of integrated tool in which the IDA Pro disassembling process is available, and debugging process is available. So like that, there are so many functionalities available in this kind of integrated tool, and which are available in market right now. But the basic tools which is used by the malware analyst, these are only DBG for user mode debugging and WinDBG for the kernel mode debugging. And only DBG is a powerful tool than whatever the built-in functionality of debugging given in the IDA Pro. So you can go with the IDA Pro debugging process also, and you can check the same thing in only DBG, and you can identify the differences between these two. Okay. Next part is about the source level and assembly level debugging. See, source level debugging is it is a process which allow a programmer to debug while coding. That is the source level debugging process. This type of debugger is usually built into the integrated development environment, and it allow us to set the breakpoints which stop on lines of source code in order to examine the internal variable states and to step through the program execution one line at a time. So we can utilize this breakpoint functionality in the source level debugger. While if we are talking about the assembly level debugger, so it is also known as low level debugger and operate on assembly code instead of the source code. Okay. Normally source code, that is a higher level language that we use to do or implement in C, C++ or any Java and all the kind of languages. Okay, that is the source code level, and assembly level code, that is low level language code, right? And assembly level debugger is operate on assembly code rather than source code, and malware analysts are usually forced to use them because they don't have a source code. That's why what we are doing in static analysis, first we disassemble the code using the IDA Pro and okay, find out the assembly level functionalities, okay, to identify the source code functionalities for the particular malicious program. Okay. See here, one screen is given about how to find the crashes in executable code, and in this three options are available, that check online for the solution, then close the program, or either you can debug the program. So usually in WinDBG, the debugging process of Windows is available. Okay, and you can identify the problem signature, then event name, timestamps, then fault module details, versions, etc. Okay, next part is the kernel versus user mode debugging. See, already we have learned about the kernel mode and user mode in while we have analyzed the Windows malicious code, okay, in chapter 7. So it is more challenging to debug the kernel mode code, okay, than the debug the user mode code, because we usually need two different systems for kernel mode. And in user mode, the debugger is running on the same system as the code is being debugged, right? So when debugging in user mode, we are debugging a single executables, okay, which is separated from other executables by the operating system. And kernel debugging is performed on two systems because there is only one kernel, and if the kernel is at a breakpoint, no application can be running on that particular same system. So that's why while we are applying the kernel mode debugging, we use to run on means two system is required. Okay, and there are different software packages for user mode and kernel mode. And normally WinDBG is currently utilized for to support the kernel mode debugging, and OLEDBG is utilized for the user mode debugging. In user mode debugging, debugger runs on the same system, right? And this means we all have this practice. when we are implementing something in C or C++ or in Java, we used to go with the debugging process, and we also check the line by line tracing. Okay, through the tracing, we can identify what happened at each point of instruction. Okay, so it is the user mode debugging, and we know that how it is utilized. And for that, separate it is a separate from other executables by the operating system. So no any more means only one system is enough to do the debugging at the user mode. Okay. But in kernel mode, two operating system is required. It is the older way. The two machines must be connected with each other. And in a new way, that here you can see that the Mark Ruzinovich live KD tool, it allows us to debug the kernel with only one computer, and it is much easier, and tool has some limitation, but we will discuss this in next chapter. Okay. See, all we are familiar with this window about advanced boot options in Windows 7 and Windows 10. Okay, and normally by pressing F8 during the startup, we can find out the debugging mode of operating system. If you haven't tried this anytime, then I suggest to go with this and try to debug, apply the debugging mode and check what happened in the operating system. Okay, here some side effect of debug mode is given, that screen key causes the viewers OD, then please label machine in S214 that you place in the debugging mode, and means if your PC has any problem and it couldn't handle, then again it will show you the message about the restart. Just go through this video, which is link is his name is given about the exploit development for the mere mortals, and here he has given a good introduction of the Oli DBG tool. The next part is the using the debugger. Basically, there are two ways to debug a program. The first is to start the program with the debugger. When you start the program, it is loaded into the memory. It stops running immediately prior to the execution of its entry. And at this point, we have complete the control of the program. Okay, this is the first step. And also we can attach a debugger to a program that is already running, and the program's thread are paused, and you can start the debugging. Okay, and it is also a good approach. So when we want to debug a program after it has been running, means after it is in execution mode, and if we want to debug a process that is affected by the malware. Okay. See, one way to use the debugging, that is the single stepping process. It is a simplest way to use the debugger. And when we run a single instruction and then return to the control to the debugger. This is the simple process of single stepping, and it allows us to see everything going on within the program, line by line, right? And it can take too much a longer time. It is a little bit time consuming process, but a single stepping is a good tool for understanding the detail of a section of the code. Okay, so I think it is better to go with this also, to identify each and every line of the code for better understanding about the functionalities. See here, one example is given about stepping through the code, and here we can identify the listing of data addresses and modified in the loops. And see here, keyword data type label with one value, that we can identify the data value at this point 1. Okay? And it doesn't appear to be ASCII text or any other recognized value. So we can use a debugger to step through this loop to reveal what this code is doing. Okay, here just a move instruction, then one looping is processed. Okay, it is about the exclusive or functionalities. Okay, so with the single stepping through the section of the code, we can identify what exactly happened. Okay, so single step through this loop is either in VDBG or OLEDBG. We could see the data being modified, and for example, here in second figure, we can see the 13 bytes modified by this function, changing each time through the loop. And this listing shows that the bytes at those addresses along with their ASCII representation. With a debugger attached, it is clear that this function is using a single byte exclusive OR function. That here it is mentioned, and to decode the string of the load library A. Okay, and it would have been more difficult to identify that string with only static analysis. See, using the IDA Pro, just we disassemble the code. Okay, but using this debugger, we can identify each and every instruction in detail. So here this is our output, and we can just see the things how it is 13 bytes modified for by each functions. Okay, and this can be shown in the second layout. Now, what is the difference between stepping over and stepping into? So with a single stepping process, the debugger stops after every instruction. Okay, and line by line checking has been done in the single step. That you can say like that. So, however, while we are generally concerned with what a program is doing, and we may not be concerned with the functionality of each call. Okay, for example, if your program calls a function like a load library, and we just want to know about the functionality, which are the functions. Okay, then we can just move to the stepping over functionality. But if we want to go in detail for each and every instruction, then we can choose the stepping into debugging process. Okay? So to control the instruction that we see in our debugger, we can step over or step into instruction. And when we step over whole instruction, we bypass them. Okay. For example, if we step over a code, then a new instruction you will see in your debugger will be the instruction after the function called returns. Okay. On the other hand, what happens in stepping into process? When we step into call instruction, the next instruction that we will see in the debugger is the first instruction of the call function. So we can say that the stepping over allows us to significantly decrease the amount of instruction that we need to analyze, but at the risk of missing this important functionality if we use the step over, and sometimes it misguides us. That also may be possible. So better to go with both the functionality while we are doing some dynamic malware analysis practice. Use the stepping over definitely to decrease the amount of code and whatever the functionality exactly that you want to identify. Then you can use the stepping over, and to know the details of each and every functionality for each and every instruction, stepping into is the best debugging way. Here I would like to say that it is a good time to use the VMware's record and replay feature. When you step over functions that never returns, you can replay the debugging session and correct your mistake. So start a recording when you begin debugging. Then when you step over a function that never returns, stop the recording and replay it to just before you step over the function. And then stop the replay and take control of the machine, but this time step into the function. So VMware's record and replay feature will be utilized in better way while we are applying this stepping over and stepping into in the dynamic malware analysis process. Okay, so just explore these features of the VMware. It will be helpful. Okay, now next part is about the pausing execution with the breakpoints. See, what is breakpoint? First of all, it is, we can say that it is the program broken somewhere. Okay, so breakpoint are used to pause the execution and allow you to examine the program's state. Okay, and when a program is paused at the breakpoint, it is referred to as a broken. Right? For example, here in this code, the call to EX function is given, and you can't tell where this call is going. So to identify where this calling is going, we should set the breakpoint. Okay, and we can check what happened the next, right? See here, this we set the breakpoint here at create file W. This is the call for the call instruction, and then look at the values on stack when breakpoint is triggered, right? So in WinDBG window, you can identify here the create file value status, okay, using the breakpoint to see the parameters of the function call. And we can examine this parameter, right, using this WinDBG debugger. Okay, now about the encrypted data. Suppose malware sends the encrypted network data, then what happens? How will you check? How will you debug that code? Right? Imagine that we have a piece of malware and a packet capture. And in that packet capture, we see the encrypted data. And we can identify a code to send, and we discover the encryption code. But it is difficult to decrypt the data ourselves because we don't know the encryption routine or a key. So in that case also, we can use the debugger, right? So at that particular point where we identify any encrypted data in that captured file, we can set the breakpoint before the data, okay, and we can identify and analyze what in detail what happened. See here in this figure, we can identify one call functionality with encrypted data. So set the breakpoint here, and let's see. In OLEDBG, the display buffer in memory, and prior to the beginning set to the encryption routine. Okay, here we can see this line of the encryption function code, right? Here some call simple se.encrypted data. This functionality is identified with the calling instruction, and in this case the data being sent in is a secret message, that is simple SE secret message, as we can show this ASCII column in the bottom right part, this one ASCII secret message, right? Here hexadecimal value is also given. So you can use several different types of breakpoints, including software execution, hardware execution, and conditional breakpoint. And it is very good feature to analyze the code in detail and to identify the particular functionalities for in dynamic malware analysis. So now I think you all know about what is the importance of debugging process in advanced dynamic malware analysis, and how can we run the code through step into process or stepping over process. Okay, these are the two way of debugging process, and how to utilize the OLEDBG and WinDBG debugger. So in next lecture, we would like to explore more in detail about the types of debugger.